galaxy will experience the greatest upheaval in its history. That is when it collides with the Andromeda Galaxy. If our civilization still exists in the solar system or elsewhere in the galaxy, our very distant descendants will witness a spectacular sight, although it is preparation for one of the most violent events possible in the universe. Earth and our entire solar system exist within a massive structure called the Milky Way galaxy, which contains at least over 100 billion stars. This galaxy belongs to a larger collection called the Local Group, a group of more than 50 galaxies where the Milky Way is the second largest giant after Andromeda. In the sky, on clear moonless nights, you can see this galaxy even with the naked eye as a faint, hazy patch in the constellation of Andromeda. This is also an interesting target for amateur observers as it appears clearly even when viewed through ordinary telescopes. For astronomers, observing this galaxy plays many roles in understanding the evolution of galaxies in general as well as our own galaxy in particular. Because it is quite close and the largest galaxy in the Local Group, with a spiral structure similar to the Milky Way. Andromeda is an excellent specimen for observing and testing models of galaxy structure and evolution that astronomers currently have, thereby improving our understanding of galaxies in the universe, especially about our own galaxy. Observations by astronomers show a blue shift in the spectrum obtained from the Andromeda Galaxy. Simply put, blue shift is the phenomenon where the light received corresponding to one or some elements emitted from a galaxy or star has a shorter wavelength than its usual wavelength. Since each element emits its characteristic wavelength, obtaining a shorter wavelength than usual indicates that the source here is the observed galaxy or star moving closer. This phenomenon is called the Doppler effect. Conversely, if the observed galaxy or star is moving away, astronomers will see the received wavelength longer than the original wavelength, called red shift. Today, astronomers know that the universe is expanding in all directions. Clear evidence of this is the observation of red shift in the spectra of all distant galaxies. This was first discovered in 1929 thanks to the observations of Edwin Hubble. That might make you wonder. So why do we observe blue shift in the Andromeda Galaxy if the universe is continuously expanding? The answer lies in distance. Hubble's observations show that the farther away a galaxy is, the faster it moves away from us. From this, he formulated Hubble's law, where the recession velocity of a galaxy is proportional to its distance. This means that at smaller distances, the expansion of the universe is less apparent, or in other words, whatever causes the universe to expand has a very weak effect at close range. Meanwhile, all massive objects in the universe exert influence on each other's motion through their gravitational fields. And as Newton's famous formula tells us, the magnitude of gravitational force is inversely proportional to the square of the distance, meaning the closer, the stronger the gravitational force. The contrast between these two things causes galaxies to move away from each other significantly at large distances. But conversely, for small distances, specifically 2.5 million light-years separating the Milky Way and Andromeda is very small when considered on a galactic distance scale. At that distance, the enormous masses of these two galaxies cause them to exert gravitational influence on each other much more significantly than the movement due to the expansion of the universe. That's not that the universe doesn't. You still move forward, but overall, you are pulled backward. Currently, a measured blue shift coefficient shows that the Andromeda galaxy is approaching our galaxy at a velocity of about 110 kilometers per second. However, this velocity is not fixed, but will increase over time as the distance between the two galaxies continues to shorten. According to astronomers' estimates, the time when the collision begins will start in about 4.5 billion years. What will happen and what fate awaits the galaxy as well as our planetary system? Based on theoretical calculations and detailed computer models, most astronomers agree that the result of the collision between these two large galaxies in the future will lead to the formation of a new galaxy from the combination of the two galaxies. Such galaxy mergers are not too rare in the universe. Andromeda itself as well as the Milky Way are thought to have merged or swallowed some small galaxies called dwarf galaxies before they became as large as today. This approach and merger process certainly has significant consequences for both galaxies as well as the stars and planets within them. However, it might not be as most people imagine. First, collisions between stars and planets like in many science fiction movie scenarios basically will not occur. Although looking at astronomical photos, you might see that galaxies such as Andromeda look like a chaotic mass filled with stars. The reality is that the density of stars in galaxies is very low. For example, most simply, in our vicinity, the nearest star to the Sun is already 4 light years away from us, while the distance from Earth to the Sun is 8 light minutes, and from Earth to the Moon is just over 1 light second. This means that the gaps between stars in the galaxy are much larger than the size of stars and planets. The probability of two random stars colliding with each other is many times more difficult than you and someone else throwing two very small grains of sand from opposite ends of a football field towards each other and hoping they will collide midway. Thus, it can be said that there is almost no chance of another star from Andromeda or even from the Milky Way itself crashing into our solar system. But that doesn't mean the solar system will be completely safe. In fact, the impact of Andromeda doesn't wait until the collision begins. The gradually shortening distance causes the gravitational force between the two galaxies to strengthen and directly affect the orbits of stars in both galaxies. Millions of years before the collision begins, the Sun's orbit begins to be affected. Although the density and precise orbits of stars in Andromeda haven't been observed in enough detail to draw firm conclusions, it is quite likely that stars located near the edge of the Milky Way like the Sun will be ejected from the galaxy when the collision process occurs. That ejection process will also somewhat change the structure of the planetary system. Earth and the planets will no longer have orbits as they do now. Being pushed out of our current orbit has had clear consequences for our planet. Imagine if the distance from Earth to the Sun increased or decreased by just 1.5 times, what would happen? Temperatures would change significantly. Much colder if farther from the Sun and hotter if closer. The annual cycle and weather would completely change. Tides, earthquakes, and tsunamis would occur in different cycles, possibly more dangerous or not, along with many other consequences. Of course, if the orbital change isn't too large, specifically remaining between the current orbits of Venus and Mars, then over millions of years, many species would have enough time to evolve and adapt. To know for sure whether this change is within that limit or if Earth will be pushed to the edge of the solar system, or conversely, into Mercury. In both of those cases, life would have no hope of survival. In reality, you don't need to worry about the scenario just mentioned. Calculations, the Sun. That increase in radiation will heat Earth to the point where all liquid water evaporates from the surface, and essentially, life will no longer exist by that time.
Also, during those over 3 billion years, our future generations continue to exist and develop science and technology.
They would likely have exhausted Earth's resources and had enough time to create means to travel to other planetary systems in the galaxy. Even if humanity doesn't go extinct after that period, evolution would certainly have transformed our descendants into beings less resembling modern humans. Because don't forget, dinosaurs only went extinct about 65 million years ago, when mammals had none of the physical characteristics resembling humans or today's primates. If they exist and develop for another 3 billion years, the civilized species on Earth would then have the capability to easily travel between planets and survive the upheavals caused by the merger of two galaxies. In over 3 billion years, any living organisms remaining in the Milky Way will witness a spectacular sight when a giant galaxy appears across a vast area of the night sky. Moreover, galaxies in a local group will continue to merge and could become a single giant galaxy. However, that's a story for at least 150 billion years from now, when most stars in the galaxy have died out
And star formation activity has nearly ceased.
The giant galaxy formed then will be an old elliptical galaxy with the only bright area being the central region, where there is a supermassive black hole,
larger than the current black hole at the center of the Milky Way.
It continues to draw in surrounding gas and dust.